Dear students, today we are going to talk about transistor being used as an oscillator. Means it is simply an amplifier having positive feedback. Means whatever the energy is being amplified, some part of that is brought back to the input, that is called positive feedback. And we will learn more about it in some higher classes where we have feedback circuits studied in details. Now it is nothing but the usually and commonly called the inverter circuits. The inverter is the very much integral part of our day-to-day domestic lives, where we get electricity from the energy stored in the battery in the form of alternating current, which serves the purpose whenever there is power cut or some disruption due to natural calamities. Here you see we have a transistor, the simple one. The most preliminary inverter circuit can be made by this using a transistor, which is we have taken for a particular case. We have taken NPN transistor, which is being used as an oscillator. What we do is we keep the transistor in common emitter configuration, and then at the input we have a LC circuit. The L is the inductance coil, value of inductance of the inductance coil, and C dash is the capacitance of a capacitor, both kept in parallel and then connected to the forward biasing battery B1. The coil L is mutually coupled with another coil L dash, and also it is coupled with yet another coil L double dash. That means the same three coil, of course coil is made of insulated wires, same three coils are wounded over the same core material, so that they all remain mutually coupled with each other. Now we keep the output circuit, that is emitter, that is collector circuit, to be reverse biased, and for that what we need is attach the positive terminal to the N type, that is collector is N type, base is P type, and emitter is N type. Therefore we have NPN transistor. We keep a key over here to control the current flowing in the circuit. Now let us understand how this circuit works. Let us take that initially the key K is off. That means no current will flow in the collector circuit because the circuit is broken over here. Though we have already applied some forward bias in the input, the collector current is 0 because the circuit is open. Now we start talking from this point onward. When the key K is put on, the moment it is put on, the collector current starts increasing from its 0 value to certain value, but that is the saturation value. But the moment it starts increasing, the collector current starts increasing due to mutual inductance between coil L dash and L. Some EMF, back EMF, is induced across the coil L because L and L dash are mutually coupled. Due to this induced EMF across the coil L, the forward bias of emitter base junction is supported because this induced EMF is in the same sense as is the battery B1, and therefore these two together increases the forward bias value, forward bias voltage for the base emitter circuit, and as a result the emitter current increases, because now this back EMF induced across the L increases, supports the forward bias, and therefore the moment forward bias is supported, the emitter current will increase, and the moment emitter current increases, the collector current will also increase, because we have the relation emitter current is equal to the sum of base current and collector current. So now collector current increases further. So again there the L dash is mutually coupled with L, therefore and again EMF is induced across the coil L, and which is again supporting the forward bias, and as a result collector current again increases. So this thing happens in loop, and finally the collector current reaches the saturation current for the given reverse bias voltage, because the collector current will have a saturation value for given reverse bias voltage. Please refer to the output characteristic of the transistor. You will understand how it saturates. When we look at the curve in the output circuit, it saturates at certain value. For a given bias voltage, reverse bias voltage, the collector current saturates, and the moment it saturates, now L dash and L, they are mutually coupled. Now there is no change in current flowing through the L dash, therefore there is no induced EMF produced across the coil L, because there is no change in collector current, so there is no induced EMF across the coil L. But by the time this happens, the capacitor C dash gets charged as shown by the red marking, means the upper plate of the capacitor C dash becomes positively charged and the lower plate of the capacitor C dash becomes negatively charged. Now there is no EMF induced across the coil L when the collector current is saturated. Then in that case the capacitor C dash starts discharging, and this discharge will be in a direction, reverse direction, means it will move from in anti-clockwise direction, and therefore the forward bias of the emitter base input circuit will be decreased due to the flow of current as the C dash discharges, and as a result the forward bias is reduced. Once the forward bias is reduced, the emitter current is reduced, and therefore the collector current is reduced. Once the collector current reduces, as coil L dash is mutually coupled with coil L, therefore now an EMF which opposes the forward bias of input is induced across the coil L, because while the IC was increasing, induced EMF was in one sense supporting the forward bias. Now while IC is decreasing, the induced EMF will be in opposite sense, and as a result it will oppose the forward bias, and as a result the emitter current decreases, again further a collector current decreases, and this thing happens in loop again and again. So each time the collector current decreases, EMF is opposing, produced across L is opposing the forward bias, and finally at a stage will come when collector current finally becomes zero, as if this circuit is again open. The output circuit virtually acts as if it is open, and once this happens, the whole cycle is completed, and once there is no impact of mutual inductance between coil L dash and L, and then the back EMF produced across the L also vanishes. Once this happens, now the capacitor C dash, which has been now charged in reverse sense, means now the bottom part of the capacitor was positively charged and upper part was negatively charged, and now once this collector current becomes zero, there is no induced EMF across the coil L. Now capacitor C dash, which is now being reversely charged, starts discharging, and then it increases the forward bias, that increases the collector current, and this whole process repeats again and again. So what you see is the EMF across L continuously keeps varying, becoming starting from 0, becoming having a peak value, and then becoming 0, and then finally having peak value in the reverse direction, and the whole thing repeats like this. That means a sinusoidal wave varying alternating current will be varying alternating voltage will be obtained across this coil L, and since an anticyclic coil L double dash is mutually coupled with coil L, therefore this varying AC voltage could be drawn from across the two ends of the particular coil L double dash, which is alternating in nature, and this alternating wave we have obtained by using the DC energy and converting into AC voltage and hence AC current. The frequency of this AC voltage will be given by the relation nu is equal to 1 upon 2 pi 1 upon under root LC. Here L and C, this is the resonant frequency of this oscillator, and that means we have converted a DC supply into an AC supply. Now if you want to use it for large purposes, we take the transistor of having greater capacity to handle high powers, and also we amplify the voltage by using a transformer to amplify AC. It becomes easy, or even we use transistorized circuits for amplification of AC signals, as we have just in the previous lecture we have talked about it, amplifiers using a transistor. And so that's how we get electrical energy in the form of AC from a DC source, and it is in common called inverter circuits. That's all for today. Thank you and have a nice day.